Hello, everyone. My name is Bill Rand, and I am the McLaughlin Distinguished Professor of Marketing Analytics at NC State University's Poole College of Management. And today I want to talk to you about agent-based modeling. In particular, I'm going to talk to you about one interest of agent-based modeling that I have, which is data-driven agent-based modeling. This is a talk I've been kind of working on for a little while, but I'd like to talk about like where data-driven agent-based modeling comes from, where it is, and where it's going to some extent. So, for those of you who think about things like big data on a regular basis and the fact that there's data all over and it's being processed by our generative AI systems and it's being used in all these different ways, the beauty of it is that we have all of these kind of literal footprints and fingerprints, if you will, in the digital sand. In some cases, quite literally fingerprints, right? When we're unlocking our devices and stuff like that. But all these different traces, whether it be you interacting with ChatGPT or you posting on social media about something that's happening, or even an image on Instagram or a photo that you upload, they leave kind of a representation of our social behavior and our social activity. And one thing I'm really interested in understanding is how can we use this information to better understand human behavior and to kind of create a better place in the world for us all to be, right? Can we use these signals, right? These emissions of human behavior, if you will, to explore the complexity of individuals and discover how they first find out. And in a lot of cases, in my case, when I talk about marketing, I talk about new events, products, and services, but any kind of new information, right? What I'm really passionate about is how do we provide people with better data in the right way so they can make more data-driven decisions about the world around them. And of course, the lure of big data is that we take this data, we throw it through some sort of model, and we get an output. And with that, we can solve all the world's problems, right? We don't need theories anymore that explain how human behavior works or anything like that. We just take the data of these human interactions with the digital world, and we can just predict what their next actions are going to be, right? That's going to solve all the social problems of the world. But in reality, we know that's not the case. Many of us have experience with problems that big data causes. So, for instance, I'll talk about one that's kind of a classic example in this space, which is the Google flu predictor. So, Google Flu was this tool that was built, I think it was first kind of released around 2010 or so, and it was doing pretty good in terms of predicting the likelihood of flu based upon the searches that people are entering into Google, right? And they did a great job of kind of making sure that they controlled for things like seasonality by removing any terms related to like sports engine, the sports games or stuff like that, right? So, it wasn't like, oh, every time people mention the Super Bowl, flu prevalence goes up, right? Because Super Bowl and the peak of flu prevalence tend to be close to each other, right? Not quite, right? But people start talking about it around that time, right? So they did a lot of things to control for what you would normally have issues with. And it did a really good job, as these graphs show, of actually predicting flu prevalence fairly well for a long time, right? But then around 2012, there started to be some issues about halfway through towards the peak of flu in 2012, where Google's estimates were more than double the CDC estimates. And to this day, no one knows exactly why this happened because of the fact that it was just this data model outcome kind of model. We're not quite exactly sure what happened there, right? Some people think that maybe it's just the way that people started searching for flu changed, right? So the words, the symptoms that people were typing in might have been different, or they might have been using different words at different time periods. Some people think that because some people started using the Google flu to predict Google flu, to predict actual flu, right? That affected their search behavior, right? And so they stopped searching for it as much, right? But in the end, it stopped working, and we're not exactly 100% sure why in the end. Another example of like the failure of this problem is that back in the early 2000s, the New York City decided to start to reward teachers based upon how well their students did in in various tests, right? So the better the students did, and they built a model where they controlled for like how well the pretest of the student was and how well the student had done in the previous year and things like that. And essentially what they were trying to show was that once they controlled for all that, any improvement in the student's score would be purely up to the teacher, right? The teacher would be the one who would make the difference in the student's score. And so, therefore, they can use this data, pump it through this model, this not very good model that they had, and they can predict the performance of the teacher and then compensate that teacher appropriately. A high school teacher, Rubenstein, did some work where he was able to get access to all of the scores that had happened the previous year. And in order to control for this model, he looked at people who had the same teacher in the same subject, English, math, whatever, right, in the same grade and had the same pretest score. So these were students who came in and had the exact same teacher in the same subject, same grade, same pretest score, and he looked at what their rank was when he ranked them on their final scores in 2008 versus 2009. Now, if the New York City model of how teachers do in terms of improving the scores, the ability of their students was correct, then this should be a straight line because essentially, with the same teacher, same subject, same grade, same pretest score, the teacher's ability to contribute to the student should improve by exactly the same much every single time, right? They should line up almost perfectly. But as you can see from this graph, where we started plotting all those students and their 2008 ranks versus the 2009 ranks, it's just noise, right? Meaning that there's so much that's not controlled for by this, right? Like, did the student have a bad year? Did something happen in their family? Was this particular subject a little bit tougher? Like maybe they were really good last year, but this year was worse, right? There are so many things that can affect the individual behavior of the students besides just the subject, the grade, and the pretest score and the teacher effect. That you don't see a clear relationship here. And we can't explain this graph, right? Because we don't have a theory explaining what it was on here. All we know is that it's not showing the data that we expect it to show. So, there's other examples of things like predictive policing, where, for instance, people uh, have built these systems that predict where crime is going to happen, right? But in reality, what these systems are actually doing is not predicting crime; they're predicting previous arrests in those neighborhoods, right? They're based upon the data of arrests. The problem is that we don't actually have good data about crime. What we have good data about arrests, right, for a crime, right? And so, one area where we do actually have a pretty good idea, at least in the United States, about crime is about illegal drug use, right? Because there's been years of doing these surveys where anonymous people fill out how often they take various illicit drugs, right? And according to a lot of what we see, they actually the highest group in the United States to use drugs illicitly is the white population, right? And yet, according to Predpol, which is one of the predictive policing tools, the neighborhoods, and this is specifically for an Oakland neighborhood, that should be targeted were mostly black neighborhoods, right? And so you see this disparity where because the data that we're basing our models upon was biased towards arrests in black and brown neighborhoods specifically, we get this incorrect prediction about the future. And this one we can actually almost fully explain, but this idea that just data equals best prediction and then we get the minority report scenario predicting exactly where a crime is going to happen. It's so strong that people can't get away with it. So I personally believe that all the models that we build in the social sciences and the political sciences and the policy spaces and everything like this should be interpretable from a theoretical perspective. In other words, they should not be black box. In other words, if we build a model, right, it should not be one like the predpol model where we just get a prediction, right? In this case, we know why that prediction's wrong, right? But there's no theory. Predpol is a proprietary system, and we don't know exactly what goes in to the theory of the prediction that happens in that space. And so that's not the kind of model we want to use. And I also believe that theories in general should be interpretable from a modeling perspective, i.e., they should not be unfalsifiable. If you're going to make a theoretical claim about the social world, right, there should be some way to test that claim, in my perspective. So I actually wrote this up in a book chapter back in 2019, and I call it the theory interpretable model and the model and theory interpretable theory principle, or the TIMMIT principle, which is that all social science models using big data should be interpretable from a theoretical perspective, i.e., they should not be a black box, and all social science theories applied to big data should be interpretable from a modeling perspective, i.e., they should be falsifiable. So that kind of gives us the grounding for what I'm about to start talking. You might say we haven't even mentioned agent-based modeling and data-driven work yet. Well, I'm going to get to that in the next little bit. Thanks.